Welcome. Let's solve day 9 disk fragmenter part 2 for admin of code 2024. So for this problem, it's similar to part 1. However, when we move files, we have to keep them together. So here's 9. So we have to try moving from decreasing file ID number. So we start at the highest ID and then we move from left to right. So we start at the high one, which is 9. And so we have 3 spaces available here. So according to the rules, we have to move them together or not move it at all. So 9, we can move them. So notice how it takes up 2 spaces and we're left with an empty space. Moving on. So now we decrease the file ID from 9 to 8. Notice how this is 4. So what we do is we look from left to right. So there's only 1 space available here, 3 here, 3 here, 1 and 1 and 1 and 1 and 1. So we cannot move this block of file ID 8 at all. So it stays there. 7. So this requires 3 spaces, 3 spaces. So we start here from the left. Nothing available. However, there's 3 here, so we put it there. So we move it. Moving on, this requires 6 spaces and, sorry, not 6, 4 spaces, and nothing in front of it is can accommodate 4 spaces or 4 blocks. So we leave it where it is. 5, same issue. 4 though, for this one, we can move it here, and so it goes here. So this is our final result. And then we do our checksum as before. And that's it. That's it. But notice though how, sorry, I apologize. What else? 4. I apologize. We're not done yet. And this was one of the mistakes I made earlier. 3. So 3 can't move anywhere, right? So right now, so 4 moved here. 3 can only go here, so it can't move. But now notice though, that's not the end of the file IDs. There's another, we have a file ID of 2 here. So remember, we go from decreasing file ID. So 9, 8, 7, 6, 5, 4, 3, 2. So remember, with every file ID, we start from the farthest left space. With every file ID and then we move all the way back. Well, until where they are. So for example, if we're at 6, if we're at 7, we only look for spaces in front of it. We don't need to look at spaces in the back of it. It doesn't make sense. So we always, our search space for empty spaces is always in front. It's always getting smaller and smaller. So from 4, we only look to the left. We're only looking here. We're only looking to the left. So, and we found a spot here. So that's where we move. We move to 3. 3, there are no spaces to the left of it that can accommodate 3 block size. 2, here's 2. However, 2 can move. There's 1 spot here. So that's where it moves right here. So that's the problem. I was a little bit disappointed because I could not reuse my 2-pointer approach for this problem. It's because it was different. Whereas the last problem, that when the left and the right pointer met, we were done. But on this one, we're always decreasing from 9, 8, 7, 6, 5, and then so we're moving backwards from the right side, and then the left side is always moving up to it. So it's more like a 1-pointer approach. So I think that's enough for us to get started. So let's do it. I'm actually just going to walk through it with you. So let's go through it. So what are we doing here? So we open the file, and where is it at? Oh yeah, so it's right. So what I try to do is let's consider that. Considering this, so this was that one they gave us. This was that thing here. That's this here. So let's use that. Let's use that here. We'll call this, what is it? Test 9 part 2. Test 9 part 2. Okay. So we still want the index like before. But now what we're going to do is we're going to store the location of the spaces and the files. But the spaces will store the index where it's located at, and like how many spaces, num of spaces. And the files will store something slightly different. It will store the index. It will store the num of files, or the block size. But it'll also store the file ID, its file ID. So that's what it'll store. And I think that it'll become clear why we did it like that. So what I do is I also need this is space false here to go back and forth between storing it to the spaces or storing it to the files. Okay. So I read one character at a time. If we're done with the file, we break. So all this is doing, all this first part is doing is we're populating each of these spaces and files. If it's a space, we add it here. But if it's an empty space, remember from this problem, I think, where is it at? Remember, you can have no empty spaces available. So we should ignore it because it's not going to be helpful for us. We could add it, but it'd be just a wasted. It wouldn't be of any help. So I just ignore it. So if we're at a space and we're not 0, we add it. We add the index and C, and that's C is the length of the. So notice I convert. It's a string initially, and I convert it to a string. Sorry, an integer. So this is the file size, or the blocks of spaces. And if it's not a space, then it's a file. So then it does what I said earlier. It stores these values. And this, as we run through each of these iterations of the loop, we go back and forth for a space, and we increment the index. So this index, remember, what are we doing here? So we need to know how big this thing is. So because we store this index, so we need to keep track of where it's at. So if this index was size 2, so we adjust the index depending on how big the spaces is. So if spaces is 2, index is 2 more, we move it over. If files is 3, we move it 3 over. So this is how we adjust our index. So we know where it's at. And remember though, the goal is to do this here. So let's copy that down really quick. Let me demonstrate that. So let me just go through this here. Actually, I'll put it here in a bit. But first, I want to show you what that looks like before we run this here. Let's comment this. So let's print that out really quick. I want you to see what that looks like. And we'll print the spaces and we'll print the files. So print spaces. Okay, let's print that out. So Python problem 9 part 2. Okay, so this means at index 2, there's 3 spaces available. At index 3, sorry, at index 8, there's 3 spaces available. At index 12, there's 3 spaces available. So does that match up with this here? So index 2, 3 spaces available, yes. Index 8, I think so. So there was a 1, 2, 3, 4, 5, 6, 7, 1, 2, 0. Yeah, that's fine. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yes, that's right. So again, that's how, so what we'll be doing is, now look at this one, sorry. And the file says at index 0, there are 2 blocks that are required, and this is the file ID. So that's what it is. So what we'll be doing is we'll say we have to start, remember they tell us to start from the back, start with 9. So what we'll do is we'll pop off this back eye here. So we're always starting from the back of this file's list, but on this guy we're always moving from the front. So we're looking for, remember this needs 2 spaces. This needs 2 spaces. So this one says this is the index and it has 3 spaces. And then so this will satisfy that. So what we'll do is we'll end up adjusting this. But just suppose this required 3 spaces, just suppose. And this has 3 spaces. That would mean that we can simply remove it. We can remove it. So anytime the number of spaces matches the number of files, we remove it from the spaces list. However, in this case, notice how there's 2 files and there's 3 spaces. So what we would do is we would adjust it. So now we would say, okay, your 2 files and I have 3 spaces. Your 2 files will move over here. So now this will 2 become, okay, at 2 I move, at 2 and 3 I'm putting the 2 files. So now this will become, at index 4 I have 1 space. So let's go over that really quickly. So once we put the 2 files here, now we need to adjust that. It'll say at index 4 I have 1 space. So keep that in mind and it'll become more clear in the code. So I wanted to point that out. Okay, so let's jump back to the code. Okay, great. So now we're back here. Let's see what we've got. Okay, great. So while files. So I always pop off from the back. So I always pop this guy off. And if it can't go anywhere, no big deal. There's no big deal. We just, if it can't be moved, then remember though, that's a good point. If this can't be moved, then that means the contribution will calculate it right there, because the contribution will stay here. And even if we do move it, we need to calculate it, but the contribution will be from where it is. And this contribution will be from where it got moved to. So I wanted to make that point. So let's move on. So we pop off that file. And what I do is I have a processed equals false. So let me put this back here. So what we're doing is, so we'll loop through all of the spaces now. So 2, 3. This one says, okay, is the space index bigger than the file index? Because remember, we can't going back over here, if we're looking at, for example, this 3 here, we don't want to look at the spaces back here. It wouldn't make any sense. Remember, we're trying to move these files closer to the front. So that's why we perform this check here. So if the S index is greater than the F index, what do we do here? Let me think. Processed equals true. Yeah, so fine. So the S index here is, yes, it's fine. Yeah, so it means if we go past, it means if we're past, if the space index is over here and we're here at this 5, that means at this point we can't move 5 to the front. So we need to just calculate the contributions. So let me say that again. If at some point the spaces is here but we're dealing with this 5 file. Well, we know that at this point we were unable to find a spot where these file blocks could move altogether. So that means we need to we can calculate their contribution at this point. So I put processed equals true, and but what I could have done is because I also have the same thing down here at the end, if not processed. So I can probably just do break here. So notice I have a breaker because we don't need to keep searching the spaces anymore. We can break and then calculate the contribution. So the contribution. So how does that work? How do we figure that out? So that's not too bad. So if we're looking at this here, so let's look at this one here. We were unable to move this. So at currently 8 is at the index 36, and there's 4 of them. So normally what we'd do is we would do something like 36 times the file ID, and then 37 times the file ID. But instead what I do is I say, okay, and remember, so there's, depending on the count here, so we do 36, so there's 38 and 39. So instead I do a little bit of a trick. I say, well, I just add these up and then multiply by 8. So I say from 36 to then 36 to 40, then I just take the range and then the sum, then I multiply by the file ID. So that's just a little bit cleaner. So again, if the space index passes the file index, that means I cannot move the files forward. So I break. And notice though, I also reduce the spaces. So going back over here, so the spaces currently includes all of them, right? But notice though, suppose we're here at 5. We don't need to worry about any of the spaces behind me. Same thing here at 4. We don't need to worry about any spaces behind me. So every time we move forward on the file ID, we can always reduce the spaces that we check. So that's what happens here. So that's why I reduce it. So we keep track of the space index that we're at here. Okay. And then moving forward, what else do we got? Oh yes, here. So suppose like, for example, should we check out 7? Let's try something else. 7. Let's try 7. So 7. Suppose so here for 7. And here, well, so we're gonna look through all these. So remember, this doesn't exist anymore because we put the 9s there. So now we have a 1 spot here. Remember, we have a 1 spot here, and we have 3 here. So at the 8th index, we have 3 spaces available. And over here, we can move these 7s over there. So that's what we do. So we say, okay, if the file count is less than the space count or equal, we can move the files there. So I write processed, and then the reason why I put process is because we don't want to calculate it again. So that's why I have a not process on the outside. So processed, and I know I can calculate all of them, but notice, so I calculate it differently. Now I count it from the index. So the starting index is at 8. And this is where the files will be moved. So, and then the F count. So I have 3 files, and then I do the same trick that I did over here. Starting at the S index, the space index, and I go, how many files do I need to put there? And then I just use this trick again, and then I multiply by the file ID. And then, so we know that's the total. The question becomes if they match. So in this case, the space count and the file count were the same. So that means there are no more spaces at this location anymore. So I can just remove it from spaces. It's not available to be used for any of these other guys. So I pop it off. So that means I remove spaces from that index. Yeah, I remove this index from spaces. if they match perfectly. But if it's less than, so remember I check if it's less than or equal to, I need to update it. So like remember for 9 here, I saw that there was, so the spaces count was 3, file count was 2. So I need to update this. So now the index would be at the index. Let's see. So update it. So I moved the index by the file count. So there was 2 files, so I moved it over 2. And now the number of spaces, I need to remove it by 2. And that means now I have, well, that's just updated. And then other than that, that's pretty much it. That's the whole problem. Yeah, the one thing is that I needed this on the outside. So what happened was for one of these, I didn't. I looped through all of the. I looped through it, and this. I needed to check the last one. So if I don't, let's see what happens here. I needed this here on at the end. I forgot why I didn't think. There was one file that got through the end. So I decided to put this at the end. That means, well, let's go over what that means. So if we have these scenarios, so if the space index is not bigger than it, oh, that's right, I remember now. For 8, so notice how the space index stops before 8. So this only says if it's greater than the f index. So notice here for 8, the space index will never be bigger than 8. So like if we look at all the spaces here, the biggest spaces is 35, but 8 is 36. So 8 wouldn't get processed here, and it wouldn't get processed here. So that means I had to add it here. And that's why I had to put this thing here. And so that means here, this is just convenient. So either I could leave this here or not. It's up to you. You can put it there or not. And that's the whole problem right there. Again, I was a little bit disappointed that I couldn't utilize my part 1 solution, but that's the way it goes in software sometimes. Sometimes you can use your previous work, sometimes you can't. So let's see what we'll get here. I hope that's the right answer. What is it? 2858. Yeah, so it's good. 2858. And that was it. So it wasn't too bad. It was just a lot of for these problems. For me, just try to remain calm. Try to remain calm, and try to keep it clean. If you found this enjoyable or likable or educational, please consider subscribing or liking. Other than that, have a wonderful day. Take care.